today I want to talk about, well, large language model operations, or what we call as well AgentOps, because in general, these are quite overlapping practices with very similar principles, and what kind of pieces of it you should implement in your day-to-day when developing your agentic systems. So again, not to reintroduce myself, give me 1 second, too much. I just wanted to stress the current state of my career. So we are developing agentic systems for enterprises. We are acting as forward deployed engineers in SwirlAI, as well as educating, upskilling, and training our enterprise clients, their teams. So all of this that I will be talking about today is really, well, some of it is general knowledge, but most of it is also what we apply in our day-to-day. And these are the practices that we do see work. So I wanted to frame all of this talk mainly around how to introduce specific AgentOps or LLMOps practices when looking from a perspective of AI product lifecycle, and how we develop those systems so that we can map, later on, you can map these specific practices to specific steps in your agentic system development. So starting from the very beginning, we have a problem, we want it solved, and first thing that we do, we build a prototype, right? So two parts, problem definition and prototype building. I wanted to give a shout out here to this new upcoming specialization, AI product management. And this is where AI product managers really shine, because these are also the steps in AI product development lifecycle where we can de-risk our projects the most, because we don't want to build a solution for a problem that does not need large language models to be solved. And we also want to very quickly prototype an initial solution for that problem to show feasibility of it being able to be solved with large language models. And this is where AI PMs can really shine, by very quickly prototyping and not even needing AI engineers to be in the picture. Also here, the sooner we can actually map our future to be built solution to performance metrics of our business, the greater the chances of successful deployment of our system is. So everything needs to be really tied to some specific number that business cares about, or we are risking to get deprioritized and defunded, so that our actual product doesn't really even see the light of the day. Now, these parts are where AgentOps are not necessarily yet relevant, and AgentOps becomes relevant from the next piece. So once we have built a prototype and defined performance metrics, then our goal is to build a POC or MVP as soon as possible and expose it to our users as soon as possible. And this is really where we see many practitioners make mistakes, because a POC or an MVP can be really as simple as it can get. So you can really just put out an Excel spreadsheet with a column of specific outputs, and as long as your users can find any value in it, it's already, in most cases, it's already what you should be building out, unless it's really a SaaS type of product, whether your end user is someone buying your product online. Now, the first part where we really start implementing MLOps, and this is where I think the cornerstone for MLOps is being set, is implementing proper tracing and properly attaching human feedback to your agentic system, which is operating in the backend, right? Because what we really want is to connect that feedback that we get from the users from our MVP deployed as soon as possible correctly, so that we can react to it. Then we store it in some observability platform. And this is, again, where many can start failing, because observability platform doesn't need to be some fancy tool. It can be, again, as just a regular spreadsheet, as long as we can relate our let's say, inputs, outputs of a system to a specific human feedback that is given to us by our users. Then we look into our evals. So we run our evals on traces. We look into failing evals. We look into negative human feedback on top of our traces. And that's how we decide what to improve in our system. This is very important because without knowing where our system breaks, we can't really decide where to spend money developing the system and move forward. And then once we implement some development in our system, we deploy our new version of the system as soon as possible so that we can continue gathering our users' feedback. So this part is really what it is about when it comes to agent ops, is how do we make this continuous improvement of our system, continuous loop of the improvement to our system as efficient, as fast, as secure and controllable as possible. Now, if we have properly implemented tracing and human feedback at this state, we also get most of the production monitoring for free, because we already have things like costs of our LLM calls or Gen AI calls in general. We have errors, we have latencies, perceived latencies in the form of time to the first token amounts, eval scores, etc. So we can already set thresholds on our system, which is operating in production in real time. Meaning that if we properly implemented this, we really have a good understanding of how our system is behaving. So now, how do we make this loop really work? And this is where agent ops and LLM ops come into play. And the first really important piece, as mentioned before, is really making observability right. And observability is about both tracing and human feedback. So how do you properly connect all of that so that it is as useful as possible? It is helpful to, even though we are now building quite advanced agentic systems, it is always very helpful to look into the fundamentals of tracing from the very simplest system. So the good old retrieval augmented generation, right? So we have this very simplistic naive RAG picture right here, and it shows us really what we need to do to implement proper observability. And the first thing is that we need to trace our system on a span level. So we need to trace separately queries going into our embedding models, the embedding model outputs, so the vectors that we do get when we embed our queries. We need to track the actual queries against our database separately. We need to have the actual prompt which has been rendered, including the query, retrieved context, and any other additional information passed to the system as a separate span. And then eventually we need our final output also as a separate span. Now, this could look obvious, but I still see in the market companies really just tracking inputs and outputs of the system and not treating the entire system in a proper way, meaning tracking it on a span level. Now, also important piece of this is that once human feedback is left, you always need to make sure it is properly attached to what it is targeting, right? And it's always targeting the trace. So end-to-end execution of your workflow and not to some specific span, because users only see the end-to-end. Now, if you implement this correctly, it's already halfway there, right? Because you already will have a lot of visibility into your system. Does it differ in meaningful ways when you move from RAG to agentic systems? Not necessarily, right? Because if you have a simple agent which has some planning capabilities, tools, memory modules, the only thing that is different is that your traces are now of non-deterministic length, and the amount of spans that you have in the system is also of a non-deterministic amount. So in general, you still need to trace it on a very atomic level. So each of the actions need to be traced. Is it somehow different for multi-agent systems? Again, not necessarily. So before that, again, attaching human feedback properly to where it belongs. So all of the systems, agents, multi-agent systems, or RAG type of systems, they will almost always will have some sort of a entry point and end. And the user always leaves the feedback after seeing the final output. So properly attach it to the trace and make sure that you can analyze it on the trace level. When it comes to multi-agent systems, again, very similar. The only difference is that you now have non-deterministic amount of traces because each agent generates its own trace. The length of each of the trace is also non-deterministic, and the amount of spans for all of these traces is also non-deterministic. So basically, you just don't know how many of those you will get, but you need to properly collect them into a single session eventually and properly attach the human feedback to the top level trace that connects all of the other traces of each of individual agents. So if you have your observability properly implemented, the next thing that you need to think about, and it's potentially not necessarily a part of AgentOps as you would understand it generally, but you need to think about developing your system in a minimal viable agency way, right? So you don't add agency to your system unless you really need it. So once you have your human feedback that you are developing against, and you have your evals properly set, and you know how to actually improve your system, always make sure that you only add agency when you really need that, right? So systems like simple input-output systems are sometimes the only thing that you need, right? So these are already solving powerful problems like extracting data from a doc, getting a list of outputs, again, potentially in the structured output way as the previous speaker explained, and then you use those in the downstream application. If you need to go to the virtual augmented generation level, if you need to go to Agentic RAG, where you add additional agency to the system, where you allow your part of the system to choose what kind of sources to query from, potentially rewrite the user queries and similar. If you need to go to with AI agents, and then maybe those multi-agent systems which run in a single runtime, where you can properly orchestrate them within a single runtime, and eventually only if you really, really need it. And I don't think that there are many use cases in the wild that do need that. Go with proper multi-agent systems, where the agents are potentially implemented in different frameworks, and then they communicate with via some A2A protocol. Now, a very popular, and I think one of the probably most important pieces to nail in AgentOps is the evaluation-driven development. Now, this is the lifecycle of AI system development, but the question is, how do I apply eval-driven development on top of it? Where do I really define those evals? Now, the truth is that you cannot develop a system which you cannot measure, but you also cannot just measure anything. You cannot just apply general evals all over the place and expect to be able to improve your system. So the first rule is that you only define an eval and use an eval on your system if you know how you will react to it, if you see the actual metrics changing in one or another direction. So the most useful evals are the ones where you already analyze the system and you know the failure modes of your system. So the first place where you can actually define these are here, between building a prototype and building a POC or an MVP. The case for defining evals right here is the only one, right? So we don't want to build an application which would potentially harm our relationship with our users. So if we want to already ship the first version of what we ship already needs to be good enough so that we do not damage our trust with our users. So what you can do here are probably just twofold. So one is you already you're already automating some specific workflow that has been done by humans for the, let's say, past 3 years. So you already have a bunch of historical data of inputs and expected outputs, and expected output in this case would be what a human does in that case. So we can actually define almost exact evals for specific actions that already happened in the past. So we develop against those evals. Or if we don't have any data, we start with generating some synthetic data for the intents or queries that will be coming into our system. And then either we ourselves, AI engineers, hopefully not, hopefully we have some support, really look at the outputs of our agentic system and understand where the system is failing. So the only really useful eval is the one that defines a system failure, and we know that our system really fails in those places. Because if we are writing evals for pieces or clusters of user intents or queries that we know our system already properly solves, then really there's no need to define evals there. Now the next place where we would define evals is here, where we properly attach our human feedback to a top-level trace of our application runtime. And then we look into negative feedback and we try to figure out how to cluster those negative feedbacks in specific sets of failure modes. And then we write evals for those specific failure modes. And eventually we have some evals that pop up while developing the system, because we will notice specific patterns in our system that are not optimal in some way, right? And then we define either heuristic-based or exact or subjective evals on top of our inputs. So another piece is that ideally, in the ideal case, we would really have granular evals, and we know that this is rarely a possibility in real systems for a few reasons. But before that, imagining a very simplistic agentic workflow of 2 branches that takes an intent and runs one of the branches and outputs the final answer. Ideally, we would have evals for each of those nodes, right? Because the goal here is, and evals can be per node, evals can be per branch, because evaluating a branch is also useful as evaluating the end-to-end system, or they could be end-to-end. But the goal here is simple. Given that we notice a drop in end-to-end eval of the entire system, how do we find what has failed, right? So ideally, if we do have granular evals, we would also see some drop in an eval in one of the other nodes, and then would assume that this is the cause of the end-to-end eval drop, and try to fix it, and hopefully it fixes the system. So this is what we why we would need evals in a running production system. Now, the reality is that you will rarely be able to do this, because first of all, getting proper eval sets for end-to-end evaluation is already hard. And then in order for us to really go deeper and create reasonable and useful eval sets for separate nodes inside of a system is close to impossible for each of the nodes. So at least covering some of the nodes that are really prone to failures with evals is what we should be striving for. Now, it's only useful to really have evals if we have proper versioning. Because imagine the system, so each of the node in our case would have different elements version. So one of them would be large language model itself, then parameter settings like temperature, top K, and similar. Then the prompt template, which is being fed into the LLM, inputs into that prompt template before rendering the prompt, tools available to that specific node, external context available being pulled into the context, memory, and similar. And then these 4 would be versioned, because these are really static for specific version of your application, while others are a little bit more dynamic. And you should be versioning. Also, you might need to roll back, let's say, a single branch of the system, or you might want to roll back just a one single node of the system. In general, a full branch is kind of combination of different versions of a single node, but this just showcases that the versioning per node is very important. And you can only implement this previously mentioned eval recovery, so where you notice your system going off rails and then figuring out which node is really causing the problem. So the only way you can really make sure that you're developing in a secure way and controlled way is if you properly version your agentic system. So per node versioning, make sure you have that. Then another piece is model routing, and this might be, you could say, obvious, but it is a very important piece of making sure that your system continues to operate if one of the model providers that is powering your entire system goes down or malfunctions. So basically, very simply, it's when you have a prompt, you send it to a specific model provider, you fail to get the answer back, then you retry. So a popular library here would be instructor, and eventually, potentially even that fails, right? So that's where you need model routing and your routes properly configured. So potentially you would be routing from GPT 4.1 to Llama 3.3 and expect to at least get some answer out of the system. And of course, you should also have some fallbacks that fall back to some deterministic path, right? So these are just for LLM specific routing. And then you would get an answer. Now, sounds easy to implement, not really, because if you do have properly set routes for your system, so your system is now robust because you will be rerouting if the model fails to return an answer, you will also need to have additional layer of developed system. So in this case, each of the route needs to have its own separate set of these parameters, right? So large language model is different, then the prompt has to be different in order to achieve the same result. So what that generally means is that if you implement routing for, let's say, a single reroute, you will need to have two versions of the entire system when it comes to your prompts available to you, because if you don't, then most likely you will be sacrificing quality of your system, of your outputs, when the routing actually hits. That's potentially something that you would pay, the price that you would decide to pay, because routing is not something that would happen often. So maybe the development cost of these new prompts for new models to be routed to is higher than you're willing to pay. But be sure that you always have this in mind, at least have this in mind, because you should know that this would be generally a requirement. And the final piece, by the way, I'm missing out on security, and I will not be covering security because security is, I would say, a topic of its own. But before that, there's another piece in LLMOps, which is very important, is having evals to be part of your CI/CD pipeline. So every time you really deploy an application to a new version of application and expose it to your users, you should have several layers of checks. So depending on your risk tolerance, you would have less, but for a fully fleshed out LLMOps based system, you would have a PR gates where you would have evals running against your system after each of the pull requests. And this would be where you would have least amount of evals running each time, but then you would have regression gates with more comprehensive, larger suite of evals running each time with regression tests. Then you would have some staging gates, yet another level where you would have even more security checks, etc. And potentially also having a canary release at the very end to check if your changes to the system have not negatively affected your application. So this is really theoretical, and if you implement all of this, I can guarantee that high velocity of product development would be harmed, because it's really expensive and slow to run all of these evals in your CI/CD pipeline. So you will need to hit I would say, to figure out your own risk acceptance here, because implementing all of this is almost never feasible for your organization. Now, remember that evals are not free and not cheap as well, right? Each time you run an eval, you will need to rerun your entire system to get a specific output for a specific input, right? Like, to measure against a specific reference output. Now, that means if you have, let's say, even if you have 2,000 reference examples in your datasets throughout the entire eval suite, that would mean that each time you run your evals, you would run 2,000 generations of your entire end-to-end system. And that's rarely what you would be doing, really. Now, there was quite a lot of negative in my talk, so I wanted to end it with some positive. So the tooling market is very rich, and this is probably just 20% of all of the tools that exist in the market. So any piece of LLMOps you want to cover, you will find some tooling on the market, either open source or SaaS. Really, everything is covered. So you don't need to be too scared about that. But remember that properly evaluating your systems cannot be done by tools only. You will need to look into your data a lot. You will need to understand your data. You will need to understand the failure modes of your system. And that's the only way of how you can really make sure that you are developing in a secure and robust way.